Here we go. So here's the fun one. Out of all the leading coefficient test problems, here's my favorite, and here's why, because it kind of deals with, we got to manipulate the equation a little bit to actually get what we want. So what we're doing is we're doing the end behavior. We're trying to figure out what the leading coefficient is and the degree. Well, here what we have is we have a polynomial that's not all the way kind of factored out. So what we need to do is we need to make sure we multiply this polynomial out so we can get it in descending order. So what I'm going to do is I'm going to apply the distributive property to factor out this polynomial. So 3x times x to the fourth would be 3x to the fifth. 3x times negative 5x squared would be a negative 15x cubed. 3x times 3 is going to be a 9x. So now you can see that I have distributed this 3x, so now I have a polynomial in descending order. And once it's in descending order and there's no other operations like multiplying or anything that you need to do, you have it all in descending order where you can't combine any more like terms. Now what we want to do is look for our degree and our leading coefficient. The degree in this problem is going to be 5, which is our largest exponent when it's in descending order. And also our leading coefficient, which is going to be the coefficient of that leading term, which is 3. So I'll say the degree is 5, leading coefficient is 3. Now by the leading coefficient test, since my degree is 5 and my leading coefficient is even, it's going to look very similar to my function f of x equals x cubed. I don't know exactly what this function looks like, but the cool thing about end behavior is that all the end behavior has the same thing as all the, when looking at end behavior and when they have the same characteristics as far as degree and leading coefficient, it doesn't matter what the numbers are, or, you know, well, as long as they are positive, it doesn't matter what the numbers are, they're going to have the same end behavior. So when you look at an odd and an even, I know that they're all going to fall left and rise right. Or, if we want to get a little bit more mathematical, as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity. And that's a horrible infinity, but I hope at least after here you get the message. So there you go, ladies and gentlemen. There's a couple ways to write it. I hope you enjoyed. Comment below if you have any questions, and subscribe because you love subscribing. Thanks.